Hi, this is the demo part of the hammertime presentation. I've arranged a series of virtual machines as well as a very simple registrar and a simple manufacturer signing system. The registrar is called Fountain, the manufacturer is called Highway. These are words from a song called Ripple. To best appreciate what is where, I've taken the diagram of the test network and I've made it the background image for one of my screens, and I've placed terminals on top of it with a shell from each of the machines. In A and E, you can see a TCP dump running. The background traffic you see is the periodic RPL messages and some other ICMP v6 traffic. So step one, let's start with the window for the manufacturer, which a new public-private key pair is generated and signed. The signing system was put together using the Ruby on Rails framework using OpenSSL libraries to sign. So just make this bigger so it can be seen. And what we're going to do is we're going to run the signing function with an EUI that we just created. So there's the signing function. And you saw some things go by in the background. Don't know how to build task. Of course, this command is called highway signmic rather than fountain signmic, and that's an important part. So it runs, and in this case the key pair, including the private key part, is generated on a machine with enough entropy to do this quickly. And then it would be installed via JTAG or some other mechanism to the new part in the factory while it's being assembled. That would be done, for instance, during JTAG testing on a bed of nails or some other post-assembly process. This is not that uncommon a process, and I'm told that it is, again, is done for current Cisco VoIP devices. In this demo, the act of doing the JTAG is accomplished by using SCP. So we'll just look at where the devices are. DB devices 2223, and two files have been created, and they contain useful and interesting things, a certificate, and also there's the private key. So you saw the private key was quite small because it's an EC key. So I'm going to copy those to the new device. And the private key, again, that would go by JTAG on there. And in addition, the manufacturer's anchor CA needs to be installed, as subsequent ownership voucher would be signed by that key. So this is for the new device to trust the manufacturer, and that's a very important part of this process. Ownership vouchers are not part of this demo at this point. So there we go. So now if we go to a web browser, we look at what's happening, we'll see that now we have a bunch of new keys. So I've created two of them and they're there. So that's to show the manufacturer, in fact, has a record of what he's produced. So just make this close it small again. So now let's look at new node M, this guy over here with a tiny little window. And I'll make him bigger again. And he has, we'll see, a newly created manufacturer key and MIC, P, and PEM. And so it's just been unpackaged and it's been attached to some critical equipment as a sensor, and it's ready to join the network. The join component has been separated from the RPL daemon in this work just for the ease of debugging, and it is called PEC. So we're just going to run that command. There we go. Oh, I should put something correct in here. And the answer is don't put the -I, just the name of the interface. Verbose ETH0. And some stuff happened. Now, I'm just going to go through this. There's a whole bunch of things to note about this. So let's just go up here a bit here in this output. First of all, it scanned the system, looked for the interfaces, found the certificate, and it loaded it. So it was an ECDSA key, and you'll see there's the subject alt name that you were interested in, so that went into the thing, and that's using the extension. So I've also stuffed it into the CN, but that would likely get overwritten later on, and there's a lot of reasons to keep that identity later on. So then it verified the certificate. There was a CA, this is the manufacturer CA, so that did that. And it output that. Of course, this is all debugging that you're seeing. So then it assigned this number. In this case, you'll see it's really being treated as a 6-byte EUI48 because this is really Ethernet for the demo rather than 15.4, which would have 8-byte things. And it started a neighbor solicitation at IF0, starting setup for IF0, and it did some things, joined some all routers. So let's just look at ETH0 for the moment, and you'll see that the Ethernet address is 22334400122, so that's exactly what we expected. It sent the traffic out with that address. Other things to note. Did this with embed TLS libraries. This is not OpenSSL. It's not huge and gross. It is well-designed piece of code that is designed to go into embedded systems, so this will fit. I mentioned about the EU64 already, and I mentioned that it sent out a DAD. So I'm just going to look at this one. This one is the join assistant, and we'll just make that big enough so we can all see it. And what happened here, if we look back in the history, is that, let me see here, look where it is. This is all the RPL processing. Should we do it again so we can see it again? Maybe it's too hard to see. Got a neighbor assessment. Let's do it again for fun, just to make sure that we can see what's going on here. So there we go. We see it now here. So it's received a neighbor solicitation. It has an ARA, their ARO. Well, in this case, we put all 64 bits. That's a sort of anonymity between Ethernet and 15.4. And because AROs really have 64 bits in them, this 48-bit thing got expanded out to 64 bits as appropriate. Started a query to the registrar. This was a GRASS query. 3 milliseconds later, we got reply back from the server. If we wanted to look here, we would see the traffic went up the RPL tree and down again, and that was all happened. And make that small again and look for this window here, which is, this is the registrar. And you'll see, so we saw it twice. We looked up this new thing, and we said that's probably a node we will accept. In this case, this registrar is pretty promiscuous. It doesn't do a lot of checking at this point, but that's because it's just a demo. And finally, if we look at the list of certificates, so we look at the list of things, then we should see an additional entry, and we do. And that's it for this demo.